Here shown below, Vc at t equals to 0 is nothing but 0 volts. We have to find out the capacitor current equation for t greater than 0. This is the capacitor with the source circuit. So as time increases, the voltage across the capacitance is going to increase, which will decrease the capacitance current. So we have to consider a capacitance equation first of all in order to decide the current through it. Vc of t is nothing but Vc of infinite plus Vc of 0 minus Vc of infinite e power minus t by Rc. Here Rc is nothing but 10 into 10 power 3 into 4 into 10 power minus 6. So 40 into 10 power minus 3. Here Vc of t equation is Vc at t equals to infinite, capacitor acts as an open circuit. That means the 10 volt source is equally divided between the 20 as well as the 20k. So 5 into e power minus t by 25t. So IC is nothing but C dVc by dt. So 4 into 10 power minus 6, 25 into 5 e power minus 25t. So 500, that is 0.5 e power minus 25t milliamps. The current through the capacitor is nothing but 0.5 e power minus 25t milliamps. Hence option A is correct. Schematic figure shown below, the saturated output voltages are plus or minus 10. The threshold voltages are, upper threshold voltage is 2 volts whereas lower threshold voltage is 1 volt. We have to find out the R2 for a given network. So in order to decide that one, we have to write the generalized equation for the threshold voltage. So Vt is equals to V0 10k divided by R2 plus 10k plus V reference R2 divided by R2 plus 10k. So VTH, which is 2 volts, is equals to, this is going to happen whenever V0 is positive saturated voltage, that is plus 10 volts. 10k divided by R2 plus 10k. V reference, which is unknown here, in order to decide R2, it's not required. So write the equation for the lower threshold voltage, which is 1 volt. This is going to happen whenever output saturated voltage is minus 10. Plus V reference R2 divided by R2 plus 10k. So if we subtract those two equations, that is VTH minus VTL, which is equals to 1 volt, we will get 20 10k divided by R2 plus 10k. V reference, which is unknown, is going to cancel each other. So 200k R2 plus 10k. From this equation we will get R2 as 190k. Hence option C is correct. If a signal and its even part is given as x of n and xq of n respectively, then which one of the following relationship is true? So x of n consists of both even ports as well as odd ports. X naught of n and xu of n is the even part. So summation over minus infinite to infinite x of n can be written as sum of infinite to infinite x part of n plus even part of n. So we can divide, means we can separate odd term as well as the even term. Summation is separable, no problem at all. Here we know that summation n minus infinite to 0 x of n is minus of summation n 0 to infinite x of n. Hence, this summation goes to 0. The resulting summation leads to n over minus infinite to infinite x u of n. Hence, option D is correct. Real and odd periodic signal x of n has a fundamental period of 7 and the Fourier coefficients are given as x of 15 is equals to j, x of 16 equals to 2j, x of 17 equals to 3j. We have to decide the values of x of 0, x of minus 1, x of minus 2 and x of minus 3. Here the sequence is going to be repeated with 7. So x of one sample is going to be x of 15 sample, x of second sample is going to be x of 16th sample, x of third sample is going to be x of 17th sample. But here in time domain it is real and odd. So in frequency domain it is going to be purely imaginary and odd. So x of minus 1 is going to be minus of x of 1, which is equals to minus j. X of 0 is going to be 0. X of minus 2 is equals to minus x of minus 2 plus 2, this is plus 1, so minus 2j. X of minus 3 minus x of 3, which is minus 3j. So from the given options, option A is the correct. Open loop transfer function of a unity feedback system is given by G of s, that is A over s into 1 plus st. By what factor should the amplifier gain A be multiplied so that the damping ratio is increased from 0.2 to 0.6? Here the characteristic equation is nothing. Closed loop transfer function is equals to A by s plus s square t plus a. So if we take t as a common, s square plus 1 by ts plus a by t. Here 2 zeta omega. Suppose if we compare this closed loop transfer function what we got here with the standard transfer function, we will get 2 zeta omega n as 1 by t and omega n is under root a by t. Here zeta is 1 by 2 omega n t. So 1 by 2 under root a by t into t. So 1 by 2 under root at. This is the zeta. Zeta 1 is 0.2, which is 1 by 2 under root a1t. Zeta 2 is 0.6, 1 by 2 under root a2t. So zeta 2 by zeta 1 is nothing but 3, which is equals to under root a1 divided by a2. So a2 is nothing but 1 by 9 a1. So the gain must be multiplied by a factor of 1 by 9. That is option C is correct.